Bismillahirrahmanirrahim. Assalamu alaikum. Today in this video we'll learn how to balance the neutralization reactions in just 2 steps with the help of 3 conditions. Before starting conditions, let's have a look on the steps first. In the very first step, you have to just identify the number of neutralizable hydrogen atoms in an acid and the number of hydroxyl groups in a base. And then you have to multiply the magnitude of either greater coefficient or the subscript on the deficient side. And in the second step, you have to balance the number of hydrogen atoms on the product side. Now let's discuss the first condition. In the first condition, you can observe the number of neutralizable hydrogen atoms in an acid, they are greater than the hydroxyl groups in a base. For example, the number of neutralizable hydrogen atoms over here are 2 and the hydroxyl group over here is only 1. Now according to first step, we have to multiply this greater magnitude on the deficient side. It will give us 2. We'll place this 2 over here. Now we have to calculate the total number of hydrogen atoms on the reactant side. 2 plus 2. 4 hydrogen atoms are present over here. Now according to second step, we have to balance the hydrogen atoms on the product side. Initially 2 hydrogen atoms are present over here. We have to make it 4. So multiplying this 2 with 2 will give us 4 and we place this 2 over here. Now you will see your whole equation is balanced. 2 sodium atoms on the reactant side, 2 on the product side, 1 carbon atom on the reactant side, 1 on the product side, 3 plus 2 oxygen atoms on the reactant side, 3 plus 2 oxygen atoms on the product side, and overall 4 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. Now in the second condition, you may observe the total number of neutralizable hydrogen atoms in an acid, they are less than the hydroxyl groups in a base. For example, number of neutralizable hydrogen atoms over here is 1 and total hydroxyl groups over here are 2. Now according to first step, we have to multiply this greater magnitude on the deficient side. It will give us 2. We'll place this 2 over here. Now we have to just calculate the total number of hydrogen atoms on the reactant side, that are 4 in number. 2 over here and 2 over here. So total 4 hydrogen atoms are present on the reactant side. Now we have to balance the number of hydrogen atoms on the product side. Initially 2 hydrogen atoms are present over here and we have to make it 4. So multiplying this 2 with 2 will give us 4. So we'll place this 2 over here. Now your whole equation will be balanced. Now in the third condition, you will observe unequal magnitude of neutralizable hydrogen atoms and hydroxyl groups in an acid and base respectively. For example, over here 3 neutralizable hydrogen atoms are present and 2 hydroxyl groups over here. Now we have to multiply this 3 and 2 with a number that will give us equal number of neutralizable hydrogen atoms and hydroxyl groups. For example, multiplying 3 with 2 will give us 6 and 2 with 3 will give us 6. So we will place this 3 over here and this 2 over here. Now we have to calculate the total hydrogen atoms on the reactant side. As 6 hydrogen atoms are present over here and 6 over here, so total 12 hydrogen atoms are present on the reactant side. Now according to second step, we have to balance the number of hydrogen atoms on the product side. 2 initially are present. Multiplying this 2 with 6 will give us 12. So we'll place this 6 over here. Now you'll see your whole equation is balanced. I hope you understand today's topic. For more informative videos, stay tuned. Thank you. Allah Hafiz.